Okay, hopefully you've watched the previous video and established why you need significant digits. Now let's talk a little bit about how to determine how many significant digits there are in a number. Here's the rules for determining the number of significant digits, and remember all these rules come because we need to ways to manipulate numerical data that we measure. Okay, any non-zero number is significant. So if we have the number 15 meters, there's two significant figures. I'll write SF for significant figures or significant digits. Okay, 123 liters. That has three significant digits. All three digits are significant. Okay, rule number 2, zeros between non-zero digits are significant. In fact, actually, I'm going to say zeros, I'm going to change that to zeros between significant digits are significant. And you'll see why in a second. Okay, so far I have non-zeros are significant and zeros between them are. So 105 liters, that's three significant figures, three significant digits. Okay, 2002 feet, 2002 feet, that's got four significant figures. Okay, zeros to the left of the first non-zero digit are not significant. Okay, so here's our first case where we don't have a significant digit. Okay, 0.0012. Okay, these zeros appear before the first non-zero digit, so they're not significant. The only significant digits are these. So we have two significant digits, okay, and 0.0012. Okay, how about this one? 0.0102, and we'll call that milligrams. Okay, now, again, zeros that appear before the first non-zero digit are not significant. They're called placeholders. Okay, this one, the 1 is significant because all non-zeros are significant, and the 2 is significant, and the 0 between is also significant. So there's three significant digits in 0.0102 milligrams. Okay, zeros at the end of a number after a decimal are significant. Okay, so now we're starting to get a little more complicated. Let's try this one. 0.010200. Okay, and we'll say that that is meters. All right. Now, zeros that appear before the first non-zero are not significant, so those two are not significant. Okay, the 1 is not 0, so that's significant. This is not 0, so that's significant. The zeros between two significant digits, that's significant. And then we have the 0 at the end of the number after the decimal. So we're after the decimal here. All these numbers are at the decimal. So this guy is significant, and so is this guy. So here we have 5 significant digits on that measurement. Okay, zeros at the end of the number after the decimal are significant. Let's try another one. Because that one can, this one usually starts to get people. So 5.00 liters, okay, that has 3 significant digits. All of them are significant. And the reason is we have that significant, and then zeros at the end of the number after the decimal are significant, and zeros between are, they're all significant, okay. Basically, they're significant because you're reporting them. When I write 5.00, I'm saying my measuring device goes to the tens place, and I'm estimating the hundredths place. Okay, if my if my measuring device doesn't go to the tens place, I'm not going to write 5.00 liters. If it only goes to the ones place, I'm going to write 5.0. Okay, not 5.00. So by my reporting more zeros, I'm saying my device is it has a greater level of precision. Okay? Now, zeros at the end of a whole number are not significant unless a decimal is written. Okay? So here we go with this one. 500 meters. Now, when I write 500 meters in science, if I don't put any decimal there, then what I'm saying is that, you know, I'm not even sure about this digit right here. Okay? What I'm saying is I have a measuring device, and the first mark comes at 1,000 meters. Okay? So I'm looking about halfway between, but I can't be sure, so there's uncertainty with that 5. That's what I mean by how we report it, okay? So this one only has one significant digit. Zeros at the end of a whole number are not significant, okay? So this has one significant figure. Now, let's say my measuring device is more accurate. You know, say I'm certain that I'm that of the hundreds place, and my estimation is in the tens place. So I want that tens place to be significant. I want to indicate that my accuracy or my precision is there. I would have to write that 5.0 times 10 to the second. And see, now that now numbers before a non-zero, or non-zero numbers are significant, and then zeros after a decimal are. See, so now I'm making that tens place significant by writing it in scientific notation. If I want to say that, oh, I'm quite certain it's of the tens place, and my uncertainty is in the ones place, so that I want my ones place to be significant, I can do that two ways. I can say that 500 point meters. Now, by writing that decimal, unless a decimal, by writing that decimal there, I'm saying that zero is significant, and that means all these are significant. So that has 3 sig figs. So, okay. Now, if I wanted to say that I was certain that it was 500, and I was actually, the uncertainty was in the tenths place, then I would have a choice. I could write 500.0 meters, in which case there would be 4 significant figures. Okay, indicating that I was certain about the ones place and that I was estimating the tenths place. Remember that estimated place is a significant figure, or a significant digit. Or I could write this 5.000 times 10 to the third meters, and that also has 4 significant figures. So I hope that this short video helps you be able to identify how many significant figures are in a measurement, because when you do manipulations, you have to follow the rules for adding and subtracting or multiplying and dividing numbers that have that are measured quantities. You're going to have to be able to count the number of significant figures. So hopefully that helps you.